Today, on September 19th, 2025, we stand at the edge of a new frontier. The world of digital creation is changing at an incredible pace. We are witnessing the birth of tools that were once the stuff of science fiction. Luma Labs has just unveiled its latest creation, Ray 3. This is not just another update to an old program, it is a revolutionary leap forward in artificial intelligence. Ray 3 is an AI that can generate video, but it does so with a level of intelligence and quality we have never seen before. It thinks, it reasons, it creates with a new kind of digital artistry, forever changing how we tell stories with moving pictures. This new tool promises to put the power of a Hollywood studio into the hands of anyone with an idea. Imagine being able to describe a scene and watch it come to life, not as a blurry, strange clip, but as a vibrant, high-quality video. Ray 3 is designed to be more than just a generator. It is a collaborator. Luma Labs calls it the world's first reasoning video model. This means it can understand complex instructions. It can look at its own work, find mistakes, and try again to make it better. This is a profound shift from simply following commands to actively participating in the creative process. The implications of this technology are vast and exciting. For filmmakers, it opens up new ways to visualize scenes before they are shot. For artists, it provides an entirely new canvas to paint with light and motion. For educators, it offers a way to create engaging visual aids that explain complex topics. The barriers to high-quality video production are beginning to crumble. Ray 3 is at the forefront of this demolition, equipped with features that were, until now, only theoretical. It can generate video in stunning high dynamic range, or HDR, making the colors and light feel more real than ever before. As we embark on this exploration of Ray 3, we will look closely at what makes it so special. We will dive into its core features, from its rapid draft mode to its intelligent reasoning capabilities. We will examine how it handles the difficult tasks of maintaining character consistency and creating believable motion. Most importantly, we will see how its pioneering use of HDR technology is setting a new standard for what AI-generated video can be. The future of visual media is unfolding right before our eyes, and Ray 3 is writing the first chapter of this new story. The age of intelligent creation has begun. What truly sets Ray 3 apart from its predecessors and competitors? The answer lies in a powerful combination of several groundbreaking features. At the top of the list is its advertised reasoning ability. Luma Labs claims that Ray 3 doesn't just process a text prompt, it thinks about it. The AI is built to understand nuanced directions by processing both language and visual information together. This allows it to interpret the subtle intentions behind a user's words. It can supposedly judge its own creations, identify where it went wrong, and automatically attempt a new version that is closer to the user's vision. This is a monumental step toward a more intuitive and collaborative human-AI creative partnership. Another headline feature is its ability to generate studio-grade HDR video. This is a first for commercially available AI video models. High dynamic range allows for a much wider spectrum of light and color in a video. It means the brightest parts of an image can be incredibly bright, and the darkest parts can be incredibly dark, all within the same frame. This creates a level of depth and realism that standard videos cannot match. The result is a visual experience that pops off the screen, making the generated scenes feel more immersive and alive. This feature alone signals a serious push toward professional-grade output. Beyond these major innovations, Ray 3 boasts significant improvements to the overall visual quality. Luma Labs claims higher fidelity, more intricate detail, and better handling of fast-paced motion and complex action scenes. The AI has been trained to preserve anatomy more accurately, reducing the strange and distorted figures that have plagued earlier models. It also promises a better understanding of physics, making the interactions between objects and their environment more believable. These enhancements are all aimed at achieving a new level of photorealism, moving AI video away from a novelty and toward a viable tool for serious production work. Finally, Ray 3 introduces practical features designed to streamline the creative workflow. A new draft mode allows users to generate low-quality versions of their ideas very quickly. This is perfect for rapid iteration, letting a creator test different prompts and concepts without waiting for a full, high-quality render. The model also allows for visual control, where users can draw simple lines or arrows on an image to direct the motion of objects or characters. This combination of intelligent reasoning, stunning visual quality, and user-friendly workflow tools makes Ray 3 a truly comprehensive and forward-thinking platform for the new age of video creation. To appreciate the revolution that Ray 3 is starting, we must first understand high dynamic range, or HDR. Think of a standard video, which we can call standard dynamic range. It has a limited range of brightness and color that it can display. It's kind of like painting with a basic set of crayons. You can create a picture, but the colors might look a bit flat. The brightest white and the darkest black are not that far apart. This is the technology we have been used to for decades on our televisions and computer monitors. It serves its purpose, but it doesn't capture the full spectacle of light that our eyes see in the real world. HDR, on the other hand, is like being given a massive professional set of paints with countless shades. It dramatically expands the range of brightness and darkness that can be shown in a single image. With HDR, the glint of sunlight on water can be dazzlingly bright, while the shadows in a nearby forest remain deep and full of detail. It doesn't just make the whole picture brighter, it allows for specific zones of the image to have their own intense brightness or darkness. This creates incredible contrast and depth, making the image feel more three-dimensional and lifelike. The colors are also richer and more numerous, moving closer to what the human eye can perceive. Now, let's connect this to artificial intelligence. When an AI like Ray 3 generates a video, it is essentially building each frame pixel by pixel based on its training data. Until now, AI models have been trained and designed to create SDR videos. They learn to paint within the limits of that standard flat color palette. Ray 3 is the first model to be natively built for HDR. This means its core architecture is designed to understand and generate the vast information needed for this expanded range of light and color. It is not simply applying an HDR filter after the fact. It is conceiving the scene in HDR from the very beginning. This is a critical distinction. Because Ray 3 thinks in HDR, it can make creative decisions that take full advantage of the technology. It can choose to make a neon sign glow with piercing intensity or to plunge a corner of the room into near total darkness, all while preserving the details in both areas. This gives the AI a powerful new tool for setting a mood, directing the viewer's attention, and creating breathtaking visuals. By integrating HDR at its core, Ray 3 is not just improving the quality of AI video, it is fundamentally expanding its artistic and expressive potential, bringing machine-generated content one step closer to the richness of reality itself. Every great journey begins with a single step. For Ray 3, that first step is its draft mode. This feature is a brilliant and practical addition to the creative process. When you have an idea for a video, you rarely get it perfect on the first try. You need to experiment with different words, camera angles, and styles. Waiting for a full, high-quality video to render each time you make a small change can be slow and frustrating. Draft mode solves this problem elegantly. It is a setting that allows the AI to generate a lower-quality, shorter clip in a fraction of the time. It is designed for speed and iteration, not for final polish. My initial hands-on experience began here in this creative sandbox. The user interface was clean and intuitive. I started with a simple prompt, a robot meticulously assembling a pocket watch on a wooden workbench. Within about a minute, draft mode delivered a 5-second clip. The quality was noticeably lower than the polished examples in Luma's marketing materials. The image was a bit soft, and there were some minor visual artifacts. The motion was a little jittery, but the core idea was there. I could see the robot, the watch parts, and the workbench. It was enough to know if my prompt was heading in the right direction. The true power of draft mode became clear as I started iterating. My first result showed a modern, sleek robot. I wanted something more vintage. I adjusted my prompt to a vintage brass robot with glowing eyes meticulously assembling a pocket watch. Again, in about a minute, I had a new version. This time, the robot had a wonderful steampunk aesthetic. The ability to make these rapid changes is a game changer. It encourages experimentation. It frees the creator from the fear of wasting time on a bad idea. You can throw a dozen concepts at the wall and see what sticks, all in the time it might have taken to render a single high-quality clip on an older system. This process feels less like commanding a machine, and more like brainstorming with a very fast visual partner. You are not locked into your first attempt. I continued to tweak the prompt, adding details like dim lighting from a single desk lamp and gears and cogs scattered on the table. Each time, the draft video updated, giving me a quick glimpse of how these new elements affected the scene. This rapid feedback loop is invaluable for refining a vision. Draft mode is not the final destination, but it is an essential and brilliantly executed first stage of the creative journey with Ray 3, setting the stage for the more powerful features to come. After refining my idea in the quick and agile draft mode, it was time to take the next step. It was time to engage the core intelligence of Ray 3, its reasoning mode. This is where the model moves beyond simple generation and begins to act as a thinking agent. Accessing this feature often requires a paid subscription, which unlocks the AI's full computational power. The promise is that the AI will not only create a higher quality video, but will also actively analyze the prompt and its own output to achieve a more accurate and satisfying result. It is a bold claim, and I was eager to put it to the test. I took my refined prompt about the vintage brass robot and submitted it in reasoning mode. The process was immediately different. It took longer, which was expected. But what was happening behind the scenes was far more complex. The interface provided glimpses into the AI's thought process. It showed the model generating an initial version, and then it seemed to pause and evaluate it. Luma Labs suggests that in this phase, the AI can check if it followed all instructions. For example, if the prompt said the robot has 3 fingers, the AI would check its own image to see if the robot's hand was correct. If not, it would discard the result and try again, all without my intervention. My first experience with this autonomous correction was, honestly, pretty intriguing. For a different prompt, a man digging for treasure on a beach, the initial output showed the character just rolling around in the sand. I then gave it a corrective command. "He's not really digging. Please fix this." The AI responded with text acknowledging the error, examining the scene where the character rolls in the sand instead of digging. It then generated a new version where the character was actively using a shovel. This was not fully autonomous self-correction, as I had to point out the error, but it was a clear demonstration of a reasoning and repair process that is a step above previous models. This interactive correction is the essence of reasoning mode. It transforms the process from a one-way command into a two-way conversation. The AI is not just a tool, it is an apprentice that can learn from feedback. During one generation, I saw the model's internal process make annotations on the video frames, drawing arrows to indicate where motion should be added or where contrast needed to be enhanced. It felt like watching an artist critique their own sketch before starting the final painting. While the process isn't perfect and can sometimes feel opaque, this leap toward an intelligent, self-correcting agent is undeniably the most exciting aspect of Ray 3. One of the greatest challenges for AI video models is consistency. Can the AI keep a character looking the same from one second to the next? Can it remember small but important details throughout a clip? This is where an AI's ability for visual reasoning is truly tested. An intelligent system should not just create a series of beautiful, disconnected images. It must weave them into a coherent and believable narrative. I decided to push Ray 3 on this front, testing its ability to maintain character identity and adhere to specific, unusual physical attributes, which often confuse other AI models. My first test involved using a photo of myself as a reference. I prompted Ray 3 to create a video of me walking through a futuristic city. The initial generation in reasoning mode was impressive. It created a cinematic shot of a person who resembled me, capturing some key facial features and my general appearance. The city was vibrant and detailed. However, the real test came when I asked for a correction. I prompted, "Now make the character turn and smile at the camera." The AI attempted the correction, but the resulting video featured a completely different person. It had lost the context from the initial successful frame, a common struggle for current AI chat-based systems. However, a different test yielded more promising results. I prompted the AI to create a video of a pirate with one arm, steering a ship through a storm. Many AI models struggle with this kind of instruction, often causing the missing limb to reappear and disappear between frames. Ray 3 handled this with surprising success. Throughout the generated 5-second clip, the pirate character consistently had only one arm. The AI remembered this crucial detail, maintaining anatomical consistency, even amidst the complex motion of the storm and the ship. This demonstrated a more robust and persistent form of visual memory than I had seen before. This highlights both the current strengths and weaknesses of Ray 3's reasoning. It shows an advanced ability to lock onto specific physical descriptions within a single generated clip, maintaining consistency in a way that feels like a significant step forward. However, its contextual memory across a longer conversation or between separate correction attempts is still fragile. It can lose the thread, forgetting a successful character it just created. The AI artist is talented and can create a beautiful, consistent painting. But if you ask it to make a change, it sometimes forgets what the original painting looked like and starts a new one from scratch. A video is not just a sequence of images, it is motion. The way objects and characters move is what breathes life into a scene. Believable physics and natural motion have long been a major hurdle for AI video generation. Often movements are floaty, characters slide instead of walk, and interactions with the environment lack impact. Luma Labs claims that Ray 3 features improved physics and a better grasp of high-octane motion. I put this to the test with a series of prompts designed to challenge the AI's understanding of movement, weight, and interaction. My first test was a simple but revealing one. A glass of water falls from a table and shatters on the floor in slow motion. This prompt tests the AI's understanding of gravity, fluid dynamics, and material properties. The result from Ray 3 was genuinely impressive. The AI correctly interpreted slow motion, creating a beautifully cinematic shot. The glass tilted, slid, and fell with a believable sense of weight. The water sloshed inside the glass realistically as it fell. The moment of impact was well executed, with the glass breaking into fragments and the water splashing outward. While not perfectly identical to a real high-speed camera shot, the physics were convincing enough to suspend disbelief. Next, I tested more complex character motion. I prompted, "A ballerina performs a pirouette in the center of a grand ballroom." This is difficult because it requires balance, grace, and precise anatomical control. Early AI models would often produce a mess of tangled limbs. Ray 3's attempt was elegant. The ballerina's form was well maintained, her posture was correct, and the spin was smooth. The motion wasn't just technically correct, it had a sense of artistry. The AI seemed to understand the feeling of a ballet performance, not just the mechanics of a spinning person. It chose a low camera angle that added to the drama of the scene, an intelligent, creative choice. Finally, I tried a high-action prompt, a drone shot flying rapidly through a dense forest, chasing a mountain biker. This tests the AI's ability to handle fast motion, maintain object consistency at speed, and navigate a complex environment. The resulting video was dynamic and exciting. The camera swooped and dodged between trees, convincingly tracking the biker. There were some minor visual artifacts, a common issue with fine, detailed textures like leaves and branches moving quickly, creating a slight shimmering effect. However, the overall sense of speed and motion was excellent. Ray 3 demonstrates a clear and significant improvement in rendering believable movement and physics, making its creations feel more grounded in reality. The flagship feature of Ray 3 is its native HDR generation, a first in the world of AI video. The promise is not just a brighter image, but a more dynamic and realistic one. To truly evaluate this, I needed to view the output on a compatible HDR display, as the effect is lost on standard screens. I took some of the prompts I had already tested and regenerated them with the HDR option enabled. The difference was not subtle. It was a fundamental change in the visual character of the videos. It was like seeing a black and white photograph suddenly burst into full, vibrant color. I revisited the scene of the vintage brass robot with glowing eyes. In the standard version, the eyes were bright yellow spots. In the HDR version, the eyes were piercing points of light that seemed to emit a genuine glow. The brass body of the robot glinted with brilliant, sharp highlights as it moved, while the shadows under the workbench remained deep and dark. The entire scene had a newfound depth and tangibility. The light from the desk lamp felt hot and intense, casting long, realistic shadows. This was not just a technical improvement, it was an emotional one. The scene felt more dramatic, more atmospheric, and more real. However, this powerful tool also comes with its own set of challenges. The AI, given the ability to paint with such a broad palette of light, sometimes takes excessive creative liberties. In one test of a serene landscape, the HDR generation drastically altered the color grading, shifting a soft morning light into a harsh, oversaturated sunset. The mood was completely different from what I intended. Furthermore, in some detailed scenes, the HDR renderings seem to introduce or amplify visual artifacts. I noticed shimmering spots and strange flickers in areas of high contrast that were not as apparent in the standard SDR version. Despite these quirks, the HDR capability is a monumental achievement. I generated a prompt for a spaceship landing in a neon-lit cyberpunk city at night. The result was simply spectacular. The ship's landing lights were dazzlingly bright, illuminating the rain-slicked ground with realistic intensity. The countless neon signs of the city glowed with a vibrant energy that is impossible to replicate in SDR. This is where Ray 3's HDR shines, in scenes with a wide range of light sources. It proves that AI is capable of not just mimicking reality, but creating hyper-realistic and artistically stylized visuals that were previously the domain of high-end visual effects artists. The HDR feature is a powerful, if sometimes unruly tool that sets a new benchmark for visual fidelity. After spending significant time exploring the depths of Luma Labs' Ray 3, it is clear that we are looking at a pivotal moment in the evolution of artificial intelligence. This is more than just an incremental update, it is a foundational shift in how we approach digital creation. Ray 3's introduction of an agentic reasoning process, combined with its pioneering leap into studio-grade HDR video, establishes it as a true state-of-the-art generator. It is a tool brimming with immense potential, offering a tantalizing glimpse into a future where anyone can become a filmmaker, an animator, or a visual effects artist with nothing more than an idea. The reasoning feature, while not yet the fully autonomous creative partner seen in science fiction, is a powerful first step. Its ability to understand corrective feedback and attempt to fix its own mistakes is a game-changer for the creative workflow. The system needs more polish, particularly in maintaining conversational context, to avoid inconsistencies during revisions. The user interface could also benefit from more transparency, giving the creator a clearer idea of what the reasoning agent is doing behind the scenes. However, the groundwork has been laid for a future where AI collaborators can truly understand and execute on a nuanced artistic vision. In terms of pure visual output, Ray 3 is a top-tier contender. Its handling of motion, physics, and character anatomy is a significant improvement over previous generations, producing clips that are both cinematic and believable. The HDR capability, despite its occasional quirks and artistic overreaches, is nothing short of revolutionary. It unlocks a new level of realism and dynamism that pushes AI-generated content closer to professional production quality. While it may not yet surpass the top models in every single metric, like raw detail and complex landscapes, its unique combination of features makes it one of the most exciting tools available today. In conclusion, Ray 3 earns a strong recommendation for anyone serious about the future of creative technology. It is a bold and ambitious platform that, while not perfect, successfully pioneers concepts that will undoubtedly become standard in the years to come. The future for Luma Labs should focus on refining the reasoning agent's memory and giving users more fine-tuned control over the HDR output. Even with its current limitations, Ray 3 is a remarkable achievement. It has brightly illuminated the path forward, and for creators everywhere, the future of video has never looked more exciting or accessible. The singularity of creative expression is drawing nearer.